Okay, now we are considering the image formation when the object is beyond C, that is beyond center of curvature. So here we have kept the object beyond center of curvature and we consider two light rays, that is one is coming parallel to the principal axis, and as we know this ray after reflection it passes through the focus, and another ray that is going through the focus, it strikes on the mirror through the focus. After reflection it becomes parallel. The ray that is coming through the focus, strike the mirror through the focus, after reflection it becomes parallel to the principal axis. It becomes parallel to the principal axis. So we can see here these two light rays after reflection meet at a point somewhere here, and here where these two rays met after reflection the image is formed, and the image formed is upside down, that is an inverted image, and since it formed due to the actual meeting of these two rays it is known as the real image. And when we consider the size of the image, we can see this is the size of the object whereas the size of the image is little bit reduced, so we say the image is diminished image. So when the object is kept beyond the center of curvature, the image formed, the position we can see the image is formed between C and F, and inverted image, real image, and of diminished size. This is the characteristics of the image formed when the object is kept beyond C, that is center of curvature. Now we are seeing when the object is, the third situation is that when the object is kept at center of curvature, at C, that is center of curvature. Now we can see in this case how is the image formed. Here principal axis F and C, and now we are keeping the object at center of curvature. So the object is now at center of curvature, and two rays we are considering, the one which is coming parallel to the principal axis, after reflection it passes through the principal focus, and the other ray that is coming through the focus, after reflection it passes parallel to the principal axis. So these two rays, we can see these two rays after reflection meet at a point here. So when we see the image formed here, that is at center of curvature itself. So when the object is kept at center of curvature, the image formed is at center of curvature itself, same position itself, but the image is upside down, that means inverted image is formed here. And when we see the size of the image, we can see that the size of the image is equal to the size of the object. So this is a special case we can say in case of a concave mirror. When the object is kept at center of curvature, the image formed is of same size, but the image is real and inverted. So this is the case when the object is kept at center of curvature C. Now the next situation is that when the object is kept between C and F, center of curvature and principal focus. Now we can see how the image formed in this case. In this case, concave mirror, principal axis P and center of curvature C and principal focus F. Here we are keeping the object between C and F. So this is the position of the object that is between C and F, center of curvature and principal focus. Again we are considering the same two rays. Any of the two rays we can consider out of the four that we discussed earlier. Here again the ray I am taking here is one going parallel to the principal axis, after reflection passes through the principal focus like this, and the another one that is passing through the focus After striking the mirror, it become parallel to the principal axis. So in this way, two rays after reflection met here each other, and the image is formed beyond C, that is center of curvature. So when the object is between C and F, the image formed is beyond center of curvature. And at the same time, we can see the size of the image compared to the object. Compared to the object, the size of the image is larger. So we can say the image formed is enlarged image. Enlarged image, since it is upside down, it is inverted, and since it is formed due to the actual meeting of the rays and it can be obtained on the screen, it is also known as the real image. So these are the characteristics of the image formed when the object is kept between C and F. Now, moving to the next situation, that is when the object is kept at principal focus F. When the object is kept at principal focus F, what will be the characteristics or what will be the nature of the image formed? That we can see now. So, the object is now kept on principal focus F. Now, here, two rays we are considering. Coming from this object, we are taking two rays. One ray that is coming parallel to the principal axis, as we told earlier, it passes through the ray that is going parallel to the principal axis. After reflection, it passes through the principal focus. So, one ray is moving like this. Another ray here we are considering taking that the ray that strike through the center of curvature. The ray that is striking through the center of curvature, it goes back or it reflects back through the center of curvature itself. So, the ray that is striking through the center of curvature goes back through the center of curvature itself. And it is found that in this case, the image of the object is formed at infinity. So when the object is kept at principal focus, the image formed is at infinity, and the image is again a real, inverted and enlarged size. So the characteristics of the image formed when the object is at F are the position where the image obtained is at infinity, enlarged image, real and inverted image is formed at infinity when the object is kept at principal focus. Now, moving to the last situation. The last situation is that when the object is between P and F, means between the pole of the mirror and the principal focus. This is a special case for this concave mirror, somewhat different from the other situations, because in all the other cases, we saw concave mirror forms a real image. But in this last situation, when the object is between P and F, when we keep the object between P and F, in this case, concave mirror forms a virtual image. Only in this situation, the concave mirror can form a virtual image. So, we can see how this virtual image is formed in this situation. So, here, the ray that is striking through the center of curvature, after reflection it passes through center of curvature itself. It passes through center of curvature. And another ray that strike on the mirror obliquely obey the laws of reflection and bounces back like this. So here, these two rays are not meeting actually. They are not going to meet each other. So in this situation, the object which is kept between P and F, we can see that an image is formed inside the mirror. That means inside the mirror on the opposite side we can see an image. That image we can obtain by extending back the reflected rays. When we extend back these reflected rays, we can see that they appear to meet. they appear to meet at a point behind the mirror, inside the mirror, and here an enlarged image, erect enlarged image of this object which is kept here is formed inside the mirror. So this is a special situation for concave mirror, where the concave mirror forms a virtual enlarged image. So this is the case when the object is kept between principal focus and pole. So these are the various situations in which a concave mirror can form its image, and the image formation by the concave mirror. Now we can see the image formation by a convex mirror. In case of convex mirror, the image formation takes place in two situations only. The first one is that in first situation, principal axis, and we know in case of convex mirror, center of curvature lies on the opposite side or inside the mirror, and principal focus also on the opposite side. Now in case of convex mirror, the first situation is that when the object is at infinity. So there are two situations. The first situation is that when the object is at infinity, how it forms the image, and the second case is that the object is between P and infinity, between the mirror and infinity, in between anywhere, whenever the object is there, it forms similar type of image. So in first case, the object is at infinity. So as we told, when the object is at infinity, we usually consider the rays that are coming as parallel rays. So a parallel beam of ray strike on this convex mirror, and after reflection it diverges. After reflection it diverges. So here also another parallel ray strike and it get reflected back. And when we extend back, now when the object is at infinity, we see that that object's image is formed inside the mirror as a very point-sized image. So we can understand how this image formed is by extending the reflected rays. When we extend back these reflected rays, we can see these appear to come from a point that is known as the principal focus. So when the object is at infinity, in case of a convex mirror, the image formed is at principal focus, point-sized image is formed on the principal focus. We can see the rays appear to come. It's not actually coming and meeting, it appear to meet at a point, or it appear to come from a point, that is the principal focus. Now, the second situation in case of convex mirror is the object is kept between P and infinity at anywhere, between the pole and infinity, anywhere when the object is kept. We can find the image formation in this case as the ray that is coming parallel, we know, in this case it appear to come from. In this case, it appear to come from the principal. When we extend back this ray, it appear to come from the principal focus. And another ray that is coming from the center of curve, that is passing through the center of curvature. It appear to pass from the center of curvature. That ray, this ray bounces back in the same pathway because it appeared to come through the center of curvature. And here we can see that these two rays appear to meet here somewhere in between P and F, and a diminished image. It's not a point-sized, but it is a diminished. It's not same as it is a smaller image. A diminished image but erect image is formed on the inside the mirror, or behind the mirror, we can say. So when the object is kept between P and infinity anywhere, in case of a convex mirror, it forms an virtual image, erect and smaller image is formed. So this is the case, situation in which the second case, when the object is kept between infinity and P. So in these two situations, the image formation takes place in case of a convex mirror. Now we can see the uses of convex mirror as well as concave mirror. What are the uses of convex mirror and concave mirror? Concave mirror is used in various situations such as dentist. It is used as a dentist mirror because we have seen in the last situation when the object is between P and F, it forms an enlarged image. So it is used as a dentist mirror, a barber's mirror for used as a barber's mirror, and shaving mirrors, etc. And at the same time it is used as a headlight in torches, searchlight, vehicles, headlights, etc. to produce the powerful beam of light. So these are the various uses of concave mirror. Whereas the important use of convex mirror is that it is used as a rear view mirror in vehicles. The reason is that we have seen just now the image formation we have seen in case of a convex mirror. The object which is kept in front, the image formed is virtual, smaller and erect image. Even though it produces smaller image, the image produced is erect. So it is used as a rear view mirror so that the vehicles which are coming from the back side of the vehicles can be seen. And moreover that it is projected outward, it is carved outward so that it can cover a large field of view. It can produce a large field of view in that smaller. So these are the main uses of convex mirror. Now, sign conventions for reflection. So these image formation, whatever we discussed here, the reflection of light, it is always following some sign conventions which is known as new Cartesian conventions, sign conventions or new Cartesian conventions. So we can see what is this new Cartesian sign. In this case, the pole of the mirror or the center of the mirror is taken as the origin. Always pole is taken as the origin. That means all the distances are measured from the pole. And object is always kept to the left side of the mirror. Object is always kept on the left side of the mirror. And whatever distance we are measuring from the pole to the left side, whatever distances are there, these distances are measured in negative, and the distances that are to the right side, all the distances are measured in positive. This is negative, and to the right side it is measured as positive. And all the distances perpendicular to and above the pole, always the object is also kept a left side. All the distances measured above the principal axis, that is from the pole, above the principal axis is measured as positive, and the distances below the principal axis is measured as negative. So these are the sign conventions while discussing with the reflection of light in a concave mirror. So we can see when we find the height of an image, real image, since the real image is formed upside down, the height of the image that is measured from the principal axis towards the bottom. So this is about the sign conventions. New Cartesian sign conventions we have to consider while discussing with the reflection of light from a concave mirror.